Hello everyone. Last time we have seen the molecular boiler, its different parts, their function, working principle, advantages, disadvantages, applications. Okay, so now we are going to see the next boiler, that is Benson boiler. Okay, so let us see first the different parts. Okay, so the different parts are here: economizer, radiant evaporation, convection evaporation, steam outlet, capacity. Okay, so this boiler has a unique characteristics, that is the absence of steam separating drum. Okay, which we have seen in our previous boiler. Okay, so in you can see in lemon boiler it was there, but in Benson it is, this construction is similar, but here the steam separating drum is absent. Okay, so the entire process of heating, steam generation and superheating are done in a single continuous tube. Okay, so let us see the different parts and their functions. So first is the economizer. Okay, as we have seen in our previous two boilers, economizer. Okay, so whatever the feed water is there, it is circulator circulated through this economizer tube through a feed pump. Okay, whatever the water is there, it is feeded to this economizer through a feed pump. Okay, and in this what happens, whatever the hot flue gases is there, it passes over this economizer. Okay, so that what happens, whatever the feed water is there, it is preheated. Okay, in economizer. Next, gradient evaporator. Okay, so the feed water from the economizer flows into the radiant evaporator with radiant parallel tube section. Okay, with radial radiant parallel tube section. The radiant evaporator receives heat from the burning fuel through the radiation process. Okay, in the radiation evaporator, it receives the heat from the burning fuel through the radiation process, and the majority of water is converted into the steam. Okay, so the majority of water is converted into the steam over here. Next, that is the convection evaporator. So here the remaining water, okay, most of the water is converted into the steam over here, but here whatever the remaining water is there is evaporated in the convective evaporator by absorbing the heat from the hot gases by convection. Okay, so the saturated high pressure steam is at a pressure of 210 kg per square meter is produced. Okay, and next part, that is convection superheater. The saturated steam is now passed through the convection superheater, where the saturated steam is superheated to 650 degrees Celsius. The radiant evaporator, the convection evaporator, and the convection superheater are all arranged in the path of flue gases. Okay, steam outlet. The superheated steam is supplied to the steam turbine through the steam outlet. Okay, capacity. Let us talk about the capacity of this boiler. So the capacity of this Benson boiler is about 150 tons per hour at a pressure of 210 kg force per square centimeter at the temperature of 650 degrees Celsius. Okay, so if you see the construction, so whatever the radiant evaporator, superheater, convective evaporator, economizer, they all are arranged in a above the path of the flue gases air filter. Okay, so now let us see the working of this Benson boiler. Okay, so it works on the pressure of the water, which is increased to the supercritical pressure, that is above the critical pressure of 225 bar. Okay, when the pressure of water is increased to the supercritical level, the latent heat of water becomes zero. Okay, and due to this it directly changes into steam without boiling, and this prevents the formation of bubble at the tube surface. Okay, so in Benson boiler the feed pump increases the pressure of the water to the supercritical pressure, and then it enters into the economizer. Okay, so from an economizer the water passes to the radiant heater. Okay, here the water receives the heat through the radiation and partly gets converted into a steam. Okay, so the temperature rises almost to the supercritical temperature. After that, mixture of steam and water enters into the convective evaporator. Okay, over here, where it is completely converted into steam and may superheat some degree, and finally it is passed through the superheater to obtain the desired superheated steam. This, this superheated steam is then used by turbines or engines to produce the electricity. Okay, this is how this Benson boiler works. Okay, now we will see the advantages of this Benson boiler. Okay, so first is that is it is lightweight. Okay, and it has no drum. Okay, so as it has no drum, so for this reason it is lighter than other boiler. Okay, next, that is its starting time is less. Whatever the starting timing is there, it is less compared to the other boiler, and it has up to 90% thermal efficiency. Okay, so this Benson boiler has a 90% thermal efficiency. These are the advantages of this Benson boiler. Now let us see the disadvantages of this Benson boiler. Okay, so due to supercritical types of boiler, okay, due to supercritical types of boiler, its controlling need to monitor every time for preventing an explosion. Okay, as we have seen that here is there is a supercritical, this is a supercritical boiler, so it's for its controlling there is need of a monitor for preventing any explosion. Okay, next, that is boiler control for the variable load is difficult. Okay, so this Benson boiler is difficult to control for the variable load. Okay, so these are the disadvantages. Now let us see the applications of this Benson boiler. So this supercritical Benson boiler is used in different industries to generate steam for the production of electricity or mechanical power. Okay, and the average operating pressure, temperature and capacity of Benson boiler is 650 degrees Celsius, 250 bar and 135 tons per hour. Okay, so this is what about the Benson boiler. Okay, so in this video we have seen the different parts of this Benson boiler, the working of this Benson boiler, okay, advantages, disadvantages and the applications. Now just let us once again see in Marathi. Okay, तर फर्स्ट ऑफ ऑल जे काही पाणी आहे वॉटर इट इज फीडेड थ्रू अ फीड पंप टू द इकॉनॉमायझर. इन इकॉनॉमायझर व्हॉट हॅपन्स ड्यू टू दिस फ्यू गॅसेस व्हॉट एव्हर द वॉटर इज देअर इट इज प्री हिटेड. ओके, त्यानंतर प्री हिट वॉटर कुठे येतं, हे रॅडियंट इव्हॅपरेटरमध्ये येतं. इथं ऑलमोस्ट व्हॉट एव्हर द वॉटर इज देअर, जे प्री हिटेड वॉटर असतं ते स्टीममध्ये कन्वर्ट होतं. ओके, अँड अगेन व्हॉट हॅपन्स इट एंटर्स इन द कन्व्हेक्टिव्ह इव्हॅपरेटर. हिअर फर्दर if here what happens in the convective evaporator, तर ह्याच्यामध्ये काय होतं की the saturated steam whatever is there it is superheated to the 650 degree Celsius. ओके, जे सॅच्युरेटेड स्टीम आहे ते इथं सुपरहेटेड स्टीममध्ये होतं आणि इथून जे आहे कुठे येतं, सुपर हिटरमध्ये येतं. ओके, तर सुपर हिटरमध्ये जे आहे जे काही स्टीम आहे ते इथं सुपरहिटेड बनते. ओके, सुपरहिट स्टीम तयार होते क्रिटिकल लेवलला आणि ती जी आहे नंतर पुढे इकडे पुढे पाठवली जाते टर्बाईनला वगैरे इलेक्ट्रिसिटी प्रोड्यूस करण्यासाठी. ओके, तर जर तुम्ही बघाल तर हे सर्व इकॉनॉमायझर, कन्व्हेक्टिव्ह इव्हॅपरेटर, सुपर हिटर, रॅडियंट इव्हॅपरेटर, एअर प्रिटर हे जे आहेत सगळे फ्लू गॅसेसच्या फ्लोमध्ये आहेत. ओके, सो हिअर वी हॅव सीन द इन्फॉर्मेशन रिगार्डिंग बेन्झीन बॉयलर. So today we are going to stop over here. Thank you.